are going to talk about matrices and systems of linear equations. So matrices are used to organize systems of linear equations. You solve linear equations before using elimination, substitution. You can solve by graphing. Okay, but when you have several linear systems, linear equations together, and you want to solve for more than two variables, it gets more complicated. And so we like to put them in matrices to solve. And so today we're going to solve what's called an augmented matrix. So we're going to solve an augmented matrix using elementary row operations, which I am going to explain to you today. Okay, so the first thing is, what is a matrix and what are matrices used for? So matrices is the plural. Okay, so what is a matrix and what are matrices used for? So you have a rectangular array of numbers. That's what a matrix is, and these matrices are used to organize information into categories that correspond to the rows and columns of the matrix. Okay, an augmented matrix is formed, so an augmented matrix is formed when we represent a linear system with a matrix. Okay, so we're representing a linear system with a matrix. Okay, and we can use the operations we learned for solving systems of equations and apply those to the augmented matrix. So here's a linear system, 2x minus y equals 5. So the first column is going to represent the coefficient of x. This is the coefficient of y, and this is the constant term. Okay, and then same thing here. The coefficient of x is 1, and then you have the 4, which is the coefficient of y, and then your constant term. Okay, so it's x, y, and then the last column is the constant. So the definition of your matrix is you have an m by n matrix, that's a rectangle, okay, and it has m rows and it has n columns. So the rows go first, the columns go second. Okay, and then these are just telling you what the elements are called. So when we were talking about sequences, it was just A1, the first term. This is 1, 1, not 11. It means the first row and the first column. 1, 2 is the first row, second column. First row, third column. Okay, so 2, 1 is not 21. It means you have the second column, the first row. Second column, second row. Second column, third row. Okay, and then so on and so forth. So however many rows there are, it's m, and then 1 for the first column. It goes all the way up to however many rows you have and however many columns you have. Okay, so the dimension of a matrix is m by n. And then we say that the numbers ij are the entries of your matrix. Okay, so the ij represents that it's in the ith row and the jth column. Okay, so anytime you are doing the dimension, it is m by n. Okay, and then n is the rows, n is the columns. Okay, and then when you are doing your terms, it's ij. Okay, so I is the row and j is the column. Okay, and that's kind of similar similar to what we talked about when we were doing our vectors, because we had that form with I and J. Okay, so 1, 1, first row, first column, 2, 3, second row, third column. All right, those are just 2 examples that I wanted to show you. All right, so the dimensions of the following matrices is what we are going to find here. So it says, what are the dimensions of the following matrices? So keep in mind, it's always rows by columns. M times N is how we're going to write it, and it's rows by columns. Okay, and we don't say that as X or times, we say by. Okay, so the number of rows, you have 2 rows, you have 3 columns, so this is a 2 by 3 matrix. Okay, this is 1 row, you have 4 columns, so this is a 1 by 4 matrix. All right, so we can write a system of linear equations as a matrix, and this is called the augmented matrix of the system. So we can write a system as a matrix that is called the augmented matrix. And then what we're going to write is the coefficients and the constants that appear in the equations. Okay, so it says create the augmented matrix for the linear system below. Okay, so when you create the matrix, it's the coefficient of x, the coefficient of y, keep the negative with it if it's minus, the coefficient of z, and then it's equal to 5. Okay, for this one, we have 1, 3, -1, 0, and this one would be -1. There's a no y, so 0 would be the coefficient. The plus is here, but it also applies there, so it's 4, and then 11. Okay, so this is going to be the augmented matrix. So if there's no variable, what do you put in the augmented matrix? A 0. If there's no variable, use 0 as the placeholder. Okay, so you gotta put 0 if there is no variable. Okay, so now we're going to learn about elementary row operations, and we can use elementary row operations with matrices, because if you perform any of these operations on an augmented matrix, it does not change its solution. So that's why we're allowed to do it. It's like multiplying by 1, right? It doesn't change it. So the elementary row operations that we're going to be using is that you can add a multiple of one row to a number. Okay, so what that means is you can multiply a row by a non-zero constant. So it can't be 0 because that would change the value. And then you can add that to another row. So you multiply one row by a number and then you add it to another row. Okay, it's a very similar to elimination in solving for systems. Okay, and then when it says multiply a row by a non-zero constant, you can multiply a row by any number besides 0. So you can't multiply by 0 because that changed your value. Okay, and then the last one is you can interchange 2 rows. What that means is you switch the placement of the row. So like row 1 will become row 2 and vice versa. So you can switch the placement of rows. Okay, so we're going to use the following notation to describe elementary row operations. Okay, so if you want to multiply row 1 by row 3, okay, you're going to start with the original matrix, so I'm just calling it the OG matrix, and then you're going to draw an arrow, it won't be as large as this, and you'll write 3R1, and then you'll put what the new matrix is. Okay, so the symbol, if you're multiplying row 1 by 3, is 3R1. Okay, if you want to switch row 1 and row 2, okay, then you're always drawing an arrow from the original to the new. And the way that you say what's happening, if you're switching rows, is a double-sided arrow. So this means you are switching row 1 and row 2. Okay, this one says you're adding row 1 and row 2, and you're putting the result in row 2. So you have to say where it's going, because if you're adding 2 rows together, you could put the result in any one of those rows. Okay, so you have your original, we're going to the new, and then this is how you would say that. You're adding row 1 and row 2, and you are putting that in row 2. Okay, so you're adding row 1 and row 2, the result is going in row 2. Okay, and then the last one, a lot going on here, so I'm going to put a longer arrow. So you're multiplying row 2 by 2. So the way that we say that is 2 row 2. Then you are going to add it to row 3. So you're going to add it to row 3 plus row 3. Okay, and then the result goes in row 2. So the result is going to end up in row 2. Okay, so you need to say where it's ending up. Okay, if you're just doing 3 times row 1, you don't have to say where it's ending up because you're just doing row 1. You haven't added anything together. Here you're switching row 1 and row 2, but anytime you're adding or multiplying and adding, you have to say where you are putting that in your matrix. All right, so we're going to practice doing this together. Okay, so we're going to solve a system of linear equations, and we're just going to identify what our goal is so you guys understand what we're trying to do here. So we're trying to solve a system of linear equations using an augmented matrix and those elementary row operations. So what our final result, what we want to happen is we want to eliminate the x term from the second equation, okay? And we also want to eliminate the x and y terms from the third equation, okay? Why do we do this? This is going to create a system where we can use back substitution to solve, and I'm going to show you what back substitution is. And then when you put this in the form where you eliminate the x term and the x and y terms, we call this triangular form in a matrix. Okay, I'll show you why once we talk about our goal. So if we reach our goal, okay, our matrix should look like 1, 0, 0. There'll be some constant term here, so I'm just going to write there's going to be some number there. And then we have a 1 and a 0. And then in the last column, we have some constant values here, a 1 there, and then in our last row, we would also have constant terms. Okay, so in our matrix, see how we have this triangle here? You can see it looks like a right triangle. If I were to box that in, 1, 0, 0, 1, 0, 1. Okay, and the reason why we do that is so you get a system where you have x plus some y value, so we'll just make the coefficient a, plus some z value, and that's going to equal some constant term c. And then in this row, if you don't have an x, if you just have a 1 in front of the y, you have y plus some coefficient of z, which we'll call d. We'll just go down the alphabet. and that's going to equal some number e. And then here you don't have an x, you don't have a y, but you do have one z, and that's going to equal some number f. Okay, so this is where a, b, c, d, e, and f are constants. Okay, this is going to create a system where we can do back substitution. Okay, so again, this is a triangle as well here. So if you have z equals a number, then you can plug that value in for z, and then you could solve this for y, and then you'd have z and y, and then you can plug that in for x. Okay, so when we're putting this system into an augmented matrix, our first step should always be the same. Okay, our first step is going to be to get a 1 in the upper left-hand corner. Okay, so you always want to start by getting a 1 in the upper left corner. Okay, so when you have your matrix, however big it is, your first step is to get this 1. Okay, that has to be a 1. There are different ways that you can get there for different systems, but that's going to be our goal. Okay, after the 1, so this is our first step. After the 1, you want to get zeros underneath in the first column. Okay, so you're going to get a 1, and then the next thing you want to do is you want to get these zeros. Okay, then the next step is get a 1 in the second row and the second column. So the next thing we want this to be a 1. Okay, and then you're going to get a 0 underneath that. So then get zeros below in column 2. So then you would want this to be a 0. Okay, and then you're going to repeat this process. So that means if once you get it in row 1, column 1, row 2, column 2, the next one would be row 3, column 3, and if it was bigger, it would be row 4, column 4, and then you don't have any zeros to get underneath, okay, if there's no more rows there. All right, so the first thing we're going to do is put this in an augmented matrix. Sometimes they are just going to tell you, like, oh, create the augmented matrix. So your augmented matrix is 1, -1, 3, and 4. And you really do need to do your best to keep these in columns as organized as possible. It really will help you to have them lined up appropriately. And then once you have the augmented matrix, okay, we are going to start our process here. Okay, so your first step is to get the 1 in A11. So first one, first column. Okay, so you have 1, 1, 3, -1, 2, -1, 3, 2, -2, 5, 4, 10, 14. Okay, now guess what? You already have that done, so that is excellent. Okay, so you don't have to do that step. If this was a number other than 1, because this row has it, you could also just, you could do a switch if you wanted. Okay, you'll practice that. So then our next goal is to obtain zeros under the 1 in column 1. Okay, so what that means is you want these guys to be zeros. Okay, when we get better at this, we'll actually do this in one step, but we're going to start slow for today. So if you want these to cancel out, there's a couple different ways that you can do this. You could do row 1 minus row 2 and put it in row 2. You can absolutely do that. What is something that's always going to work is you can always multiply because you have the 1. You can always do the opposite of row 1 and then add that to row 2, and we can make that row 2. Now, because we are replacing row 2, I'm going to keep row 1 the same. Okay, I'm going to keep row 3 the same. And then I'm just going to multiply. So negative 1 times 1 is negative 1 plus 1 is 0. Okay, negative times negative 1 is positive 1. 1 plus 2 is 3. Negative 3 plus negative 2 is negative 5. Okay, negative 4, sorry, well it is negative 4. Negative 1 times 4 is negative 4, plus 10 is going to be 6. Okay, so now we have the 0 here. We want to do the same thing with this. So if you continue this pattern, you can always multiply this by the opposite. So if I want that to be 0, I have to add negative 3 to it. So I can do negative 3 times row 1, add it to row 3, and make that row 3. And what that's going to do is it's going to keep these first 2 rows the same because you don't want to undo what you've already done. Okay, so if you do negative 3 times 1, you get negative 3 plus 3 is 0. Negative 3 times negative 1 is 3. 3 plus negative 1 is 2. Okay, 3 times negative 3 is 9. Negative 9 plus 5, negative 4. 4 times negative 3 is negative 12. Negative 12 plus 14 is going to be 2. Okay, so now we've done those 2 steps. Now we have to obtain a 1 in A22. So row 2, column 2 is what we want. Okay, so row 2, column 2. This was row 1, column 1. Okay, so one way you can always do that is you can multiply by the reciprocal. So you can either put like the arrow here if you're going from one step to another. You can also just put the arrow here. But if I multiply that second row by a third, I'm going to keep my first row. I'm going to keep my last row. Okay, and then my third row is going to be a 0, a 1, negative 5/3, and then 6 divided by 3 is 2. Okay, and yes, you will be dealing with some fractions, all right? And this is a no calculator section, so we're going to practice that math. Okay, and then after you obtain the 1 in row 2, column 2, okay, then I guess technically this is step 4. We're going to get the zeros below. Okay, and in this case, we just have 1 0 to get below there. Oops, I want to just have a little more room. All right, so one thing you can always do, once you've gotten the 1, just multiply by the opposite. So if this is 2, you want this to be negative 2. So we can do negative 2 times row 2 plus row 3, and that's going to give you your new row 3. Okay? you to practice multiplying to get your row 3. So you have 1, -1, 3, 4 in row 1. Row 2 is going to stay the same. If you multiply by 0, it's still 0. 0 plus 0 is 0. That's why we do it like this. -2 times 1 is -2. -2 plus 2 is 0. Now for this, you might want to write it down if you're more of a visual person. So -2 times -5/3 is -10/3. So if I'm doing -10/3 minus 4, right, it's like I'm putting it over 3 times 3 times 3. So 10 minus 12 is 2, so this is -2/3. Okay, so write down what you need to write down, that's fine. -2 times 2 is -4. -4 plus 2 is -2. Okay, so now we're going to continue the process. So I have 1, 0, 0, 1, 0. Now I need this to be a 1. So you have to get a 1 in A3, 3. So third row, third column. So the easiest way to do that is to multiply by the reciprocal. So the reciprocal has to be negative, so it ends up being a positive, times row 3. Okay, so 1, -1, 3, 4, 0, 1, -5/3, 2, and then 0, 0. This is going to be a 1. -2 times -3 over 2. These are going to cancel. Negative times a negative is a positive 3. Okay, so now you have this triangular system here. Okay, what you can do with that, I'm just going to erase it. You don't have to write the triangle on it. I just wanted you to see it. So these are your x coefficients, your y, and your z. Now we have a triangular system, so we're going to use back substitution. Okay, so we now have a triangular system and can use back substitution. So what that means is this system here, this is your x. So we have x minus y plus 3z equals 4. That's our first equation. Okay, our second equation is y minus 5/3 z equals 2. And then our last one is z equals 3. Okay, this is our system. So the first thing that you know is that z is 3. They call it back substitution because you're going to go in reverse. You're going to find z, then y, then x. If you know z is 3, then in this equation, it's y minus 5/3, and then instead of z, plug in the 3, and then we're just going to solve this for y. So when we multiply here, we have y minus 5 equals 2. We're going to add 5 to both sides, so y is 7. Okay, so now we have the y and the z. So we have x minus y plus 3z equals 4. And I'm going to plug in 7 for y. I'm going to plug in 3 for z. So you have x minus 7 plus 9 equals 4. -7 and 9 make 2. So I have x plus 2 equals 4. So I can subtract 2 from both sides. Okay, and then your final answer is going to be a point with 3 coordinates. Okay, so it's 2, 7, 3. This is your final answer. Okay, so your answer for this is going to be x, y, z. Now, you can make sure this is correct by plugging these into the original system. So 2, 7, and 3. If you guys plug those in for each one, you would be able to see that this would equal 4, this would equal 10, and this would equal 14. And if you want to do that real quick in your calculator, you can. And then your homework is mandatory. You have 19, 22, and 122. So 4 beautiful questions. All right. There you go. That's your intro to matrices.